Hi everyone, David Blakey here. The title of this video is Python os.walk. Os.walk is a very useful method for getting around a directory tree. It actually walks an entire directory tree and allows us to visit each directory and to see each file that's in each directory within a given tree. So what is a directory tree? Well, whether you're working on Windows, the Mac, or on Linux, you know that your file system consists of files and folders. Each folder contains other folders, and then those folders may contain folders and files. Here is the root of my file system, the Macintosh HD, and within it we have 6 folders. Within the users folders there's a whole group of files. Then the applications folder, there's a whole group of applications. It takes a little while to open up. Any of these entries in applications can be a folder, and so we have this kind of branching out thing going on where you can have folders within folders within folders that branch out into what we call a tree. It's just called a tree because the root leads to branches which lead to other branches and which eventually lead to twigs, and those twigs would be the files. So one Unix utility that we often use, we're not going to be learning this in this video, but one Unix utility that's very useful for walking a tree is a utility called find. If I were to give the current directory to find, dot being the current directory, it'll give me a list of all files and folders within that directory. And here we have a directory I have on my system called scripts and examples, and that contains a whole bunch of folders and files. You can see that App Engine here is a folder, and App Engine Hello World is a folder, but App Engine Hello World app.yaml, that's a file. This is another folder. Here's another file within that folder, and there are 2 other files within that folder, and then we get back down to a file within this folder. So you can see it's kind of a tree. It almost resembles a tree even here. And you can see also that we have this kind of undulating traversal where we go into each directory that we find, and within each directory show all the files and directories within that directory. So os.walk does something similar to what find does. It traverses an entire tree and shows us, allows us access to all the names of all the files and folders within that tree. It does something very similar to find, but it does it programmatically within Python, so it can be very useful that way. So let's go to that same directory, that is the scripts and examples folder on my system. Shoot, I'm not going to remember where it was. Let's see. Python scripts and examples. Python scripts and examples. Okay, so now we're in the same folder. We can do find and get the same result. What we're going to want to do is have Python's os.walk feature traverse the directory for us. And why do we want to do that? Well, if we're working in system administration, clearly we'd want to be able to do something like this, but we don't need to be able to have to work in system administration to want to look at all the files and folders in our system. We might want to do it ourselves on our own system. Perhaps you'd be interested in looking at a particular tree and seeing what are the largest files in that tree, or what are all the files, or what does the tree look like. Something you can sometimes do with an operating system. Mac lets you do certain types of advanced searching where you can say, well, show me all the files above 500 gigs, or rather 500 megs on my system. Maybe you're interested in pulling out some of the largest files and deleting them. And Mac OS can do that, and I'm sure there's some way to make Windows do that as well. But sometimes we want to do it within our program. Sometimes we might want to write a script, for example, that monitors our system, that looks for such large files and alerts us if a large file has been sitting there unchanged for a long time. Maybe we want to write a script that runs every day and makes this sort of check for ourselves. There's a lot of things that you can do on your own system, and you may, even if you're not a system administrator, want to do such things at work as well. So let's do that then. We're going to begin by importing OS because, as I said before, it's called os.walk. This means that it's part of the OS library. So we need to begin by importing OS. And then we're going to use this particular syntax that you'll have seen in the handout and that we'll be using all the time, no matter what we do, for root.dir's files in os.walk. And then we're going to put into it the name of the folder. So we could call it, say, search folder. And I think I could give it the current directory, the dot being the current directory. But I think instead I'm actually going to give it the entire root of the directory that I'd like to search. So this is just the root directory that we're going to begin with. We could, of course, give it the absolute root of all our file system, which is, this slash just means the beginning of the file system, the very root, the granddaddy of all folders in our file system. That's a Unix thing. Of course, in Windows, it would be something like this, or it would be this, right? C:\\. But we're not going to do that. We're not going to do that because we don't want to look through the entire file system. It would take too long and not good for this example. But it is something you may want to do at some point. It's kind of fun. Write a program that begins at the root or supply the root and have it go through your entire file system and tell you what the largest files on your entire file system. It's kind of fun to do something like that. It'll take several minutes to run because it actually has to visit and check the size of every single file in your system, but it can be elucidating. It's kind of cool. And it's also very powerful, and we're really into power here at Python Central. So what are we doing when we say for root.dir's files in os.walk? Well, we could just move forward and not explain it, and maybe at the end I'll explain exactly what that means. At this point, though, what I'll say is that since we're using for, we're going to be looping, right? And the question you might have is, what are we looping through when we loop through os.walk? Well, let's print the root and see. Print root. Let's just try that and see what we get. We know what file find looks like, right? We know what using find looks like. It looks like this. We see all the files and folders, and you can see that we've got maybe basically, I think, 3 or 4 directories that are at the root here that we're asking to peruse. But let's just try our program and see what we get. Well, how dare they? Okay, let's see. Let's do a clear. See what we get. Okay, interesting. What are we seeing? Let's make this just a little bit smaller and see what we're seeing here. Let's do another clear. Run it again. Okay, so I'm seeing a much smaller list than file. I am seeing a complete path that takes us to scripts and examples, App Engine, config.dir, and task list. Now, I don't know if you remember this from find, but when we do a find, we see a much larger list, but I see task list, Python App Engine, config.dir. Why don't I simplify this and see if it'll work just to make search folder into the current directory with dot. See if that'll work. Oh, it does work. Okay, interesting. We're getting a very similar result from this program that runs on os.walk as we did from the find command. Again, remember, I'm using a Unix utility here. I'm not calling Python. So the Unix utility find will take us through every single file and directory in the tree. But this is a much smaller list. And so what are we really looking at here? Well, I'm not seeing any files here. In fact, what we're seeing is every single directory within the tree. If we were to compare the two, we would see that any directory example, if we were to remove all of the file entries here, we would see the same list that we see down here. That is, the find Unix finder utility is looking through every directory and file, and it'll give us an entry for everything that it finds, whether it's a directory or a file. But what we're seeing here when we print root with os.walk is we're just seeing the directories. And we can see also that we're looping through about 10 or 11 times. So the for loop is looping 11 times. So what's it looping over? What is for looping over when we look at os.walk? In fact, what it's looping over is every single directory in the tree, what we call a node. If you're familiar with that term, in this case, a node means some place where we might branch off. In other words, a folder might contain another folder, and if it did, we'd be branching off into that folder, if you consider a directory tree to be like a tree. So we call any of these directories a node. And that node may contain twigs, which would be files, or it may contain another branch, which would be a folder. That could lead to other folders and thus branch off even further. So that's what we're seeing when we see root. So if we're looping through 11 odd times, which is how many directories are actually within the tree, what is dirs and files? Well, dirs would be any directories that are within this folder, this node, any directories that are within this folder, and files would be any files that are within this folder. So if we printed out both directories and files, we'd get an output very similar to what we see in the find utility, which gives us absolutely everything. Well, let's try that. Let's print root, and let's print dirs, and let's print files, and let's see what we get. And I'm going to print a blank line in between just so we can separate the output and make it clearer. So you see what we're doing here? For root, dirs, files, and os.walk, so for each node in os.walk that's underneath this search folder, which is the current directory, we're going to print root, dirs, and files just to see what we get. Let's see what we get. Confusing. How strange. Let's take a look. Let's start. Let me do a clear, and we'll start again. Okay. Let's take it up. All right. So what are we seeing? The first node is dot. That would be the root that we originally asked it to start traversing. And within it we see, well, this is the name of directories. There are 4 directories within the root. And then this is a list of files. So it looks like we've got root, and then, which is a string, and then files and list and then list. And then we have another root and then list and list. Another root and then list and list. So what are these lists? Well, we printed the root, which is the current directory that we're in, because os.walk traverses the entire directory tree. And dirs is a list that contains all directories within this root. And files is a list that contains all files within this root. So you see, if App Engine is the root, we have Hello World, Hello World Old, Homework, and Roles R Us. Those are folders within App Engine. And DS Store is a file within App Engine. Why don't we confirm that? Let's do an ls App Engine. We get Hello World Old, Homework, and Roles R Us. Where's DS Store? Well, we had to do an ls.a to show hidden files. That's a Unix thing. There's DS Store as well. So you can see that when we loop through os.walk, we're going from node to node. That is, we're going from directory to directory within the tree. Once we're in a directory, we want to know what's in the directory. And there are 2 things that could be in the directory, directories and files. So that's why dirs and files is a list. Each one is a list containing the entries that are directories or files within this current root directory. So what does this mean to you and me? Well, we may be interested in going through a directory tree and just writing down all the directories that are there. Or we may be interested in visiting every single file within the directory tree. Let's do that. Let's visit every single file within the directory tree. instead of printing files, I'm going to loop through files. Now you know that files is a list because I told you it was, and I showed you that it was, right? Files is a list. Sometimes it's an empty list. Here it's a very long list, right? You can see it has text files, HTML files, text files, etc. And since it's a list, we can loop through it. So we can say for file in files, print file. Great. I'm going to sneeze. I'll be honest with you, I'm too lazy to edit that out. So I hope you enjoyed it. So what are we looking at here? We're looping through os.walk, which is all the nodes in the directory, that is all the folders within the directory. And then we're looping through each file within that current directory. And for each file in the list of files, we're printing the file. We're also printing a second time an extra line just to separate things out. We could maybe print root as well, just to show what's going on. And in fact, I'm going to go even further and print a little space, a little indent for each file within the root. So let's try that. Okay, let's zoom back up and see what we got. Okay, in the current directory, we have all these files. Let's do an ls right now and see what we got. We got bio.txt, even numbers, myscript. Let's check it out. Well, there it is, bio.txt, even numbers, config.dir. All right, so going back to the output, the current directory, dot, which is Unix for current directory, contains these files. The App Engine directory only contains dsstore. The App Engine /Hello World directory, that is, once we went into App Engine, we went on into the subdirectory there, contains these two files. The App Engine Hello World directory contains these files, etc. So you can see every single directory in the tree, followed by every file that's within that directory. You can start to see just how powerful this really is. In the code, it's extremely simple. All we're doing is saying, for all these things in os.walk, give me the root directory that we're currently in, and it'll keep looping through all of them, right, one after the other. And then within that root, give me all the files within the root. Perfect. It's great, and it's so simple. It's so simple and yet it's so powerful because we can loop through in this way every single file within our file system. It doesn't matter if there's 10 files in our file system or 100 million files in our file system. It'll go through every single one. It might take a little longer if it's a much bigger file system, but it doesn't matter. It's going to go on and loop through everything. So this gives us access to every single file in our system. There's one other thing I want to show you though, because you'll notice that when we print file, we're only printing the name of the file. Now I might have a file named list.html in a lot of places, right? So I can't uniquely identify that file. If I wanted to say, where that file is, I can't just say it's list.html. That doesn't say enough about the file to allow me to locate it. Instead, I would need to somehow paste it to the root. Now these are strings, so I could easily concatenate these. All I'd need to do is add a slash and then the name of the file, and I could do that right here. I could just say root plus maybe a / plus file. And that would work. Fortunately, though, there's a nice method that is really useful to us called os.path.join. os.path.join root, file. What it does is it joins the two paths together, or in this case, the path and the file name. And it uses the proper slash. What do we mean by proper slash? Well, if you work in Windows and you're dealing with the MS-DOS prompt, you may notice that the directories are separated by backslashes. And you may have noticed in comparison that in Unix, or on the Mac, which uses Unix, the path elements are separated, the folders are separated by /. Well, that's highly inconvenient to work with. Because we're sometimes worried about platform compatibility. We don't want to have to change this script too much if we're moving to a different platform. We might have to change the search folder, for example, but we're going to have to do that anyway, moving to another system. But what we wouldn't want to do is have a very large Python script be ported or brought over to a different platform and then have to go through worrying about which way the slash is going. So we use something called os.path.join, which is aware of the slash that it needs to use to join the pieces. And so we have this join feature. So let's see what we get here. We're not going to print the root anymore. We're just going to say for file and files, print os.path.join root and file and see what we get then. Let's clear first. Awesome. Well, it looks like we've got every single file in the file system, which is exactly what we want. The last thing I can show you, which would be one particular reason why we would want to have the complete path name, is something called getSize. It's in fact called os.path.getSize, I believe. Let's try it. I'm not sure actually. Print os.path.getSize, and then we'll say root. Oh, shoot. Why don't we do it this way? We'll say path name equals, and then we'll print path name, and then we'll put path name here. Let's try that, and then I'll show you the code again. Okay, it worked. I'm going to add a print statement just to separate things out. Let's look at what we're doing here. We are looping through os.walk, which means we're visiting every folder within the tree. We're then, when we get to a particular node, that is a folder, and that is, while we're inside this block, we're now going to loop through all the files within that folder. And then we take a path name, we create a path name out of the root and the file using os.path.join, which is going to give us a full path name, as you see here. And then we are using something called os.path.getSize with the path name to get the size of the file, and the size will be given in bytes. So this is getting us pretty far along on our homework. So I hope you're paying attention. As you can see, oh, I didn't save it. As you can see, the result is each file in the file system followed by its size. Now, I wasn't aware that we have some files that are 0 size. Kind of makes me worried. I'm going to go ahead and run cat on this file and just see whether we get anything. There's nothing in it. Yeah, nothing in it. That's why it's 0 bytes. So you can see that every file in the file system is now associated with, not really associated with, it's followed by the size of the file. Again, this is extremely useful if you're a system administrator, but it can be useful for you at home, and it can also be useful for you just if you work within a file system and you want to find out something about the file. Perhaps you're interested in visiting a folder and getting the size because you want to see if anything's been added to the size. In other words, if anything has been written to the file yet. This would be one way to do it. And then, of course, there are myriad applications for this sort of thing. So once again, we're looping through os.walk, which is a special magical method that takes us through each folder in the file system. Remember, OS is our library for the operating system. We're basically telling the operating system that we want to go to a different directory. And so it keeps looping through every single directory in the tree, just automatically. And files contains a list of files within that directory. And root is the actual directory location. So we use root and file to get the complete file name with os.path.join. And then we're using os.path.getSize to get the size of each file path. Okay, that is os.walk. You tell me if it makes sense. Definitely send me questions and let me know what you think of this video. Cheers.